Hinata is a developer at Cavalogys Corporation. She is assigned to the Cavalogys Enterprise Resource Planning System Team, also known as the CERP System Team. A member of the Security Compliance Team at Cavalogys comes to her with a problem. One of the other developers has access to data in the system that only an administrator should be able to access. Documentation from his user profile setup request when he was hired at Cavalogys shows he developer role with limited access to records in the system. This developer, Simon, swears he has always had admin access and claims someone made a mistake. However, Lise, who sets up new users in the system, has documentation that Simon was never given an admin role and insists she would never make such an error. Simon's user profile has been updated to give him the proper role and remove the admin role, but the security team is very concerned about how this could have happened. They ask Hinata for her help. In her investigation, what should Hinata do first? Hinata uses Burp, a common testing tool, to manually check the user creation and login inputs to CERP. The user setup screens work as expected. Surprisingly, she finds that she is not getting an error message when she enters certain special characters into the username field on the CERP login screen. She focuses on the code related to the username field. Hinata finds the following in the user login code and knows immediately how Simon was able to get an admin role. Do you see what she sees? Do you know how Simon got an admin role? Hinata found is an example of a SQL injection flaw. How did Simon exploit it? When the username was requested on the CERP login screen, Simon entered this for his username. By inserting the single quote and the insert code with his username, the interpreter reads the code as part of the SQL statement. Simon has now given himself administrator access to the system. Flawed SQL query. Any attacker can change any user's role with just the username. What are injection flaws? Just as the name implies, injection flaws allow attackers to inject their codes through your web application to another system and run it. Select each item to learn more. When exploiting an injection flaw, an attacker sends simple text that exploits the programming syntax of the targeted interpreter, and thus can run the code on the targeted system. They can bypass firewalls and other protective measures put in place to safeguard your data. Injection flaws exploit applications that dynamically generate queries containing user input. This list outlines some common characteristics of injection flaws. Injection flaws have been on the OWASP top 10 since its inception. This risk was number 1 in the 2010, 2013, and now 2017 versions. A 2016 survey of the financial services sector found that 51% of the attacks perpetrated were injection-based. Even though ransomware and malware attacks dominate the headlines, injection attacks are actually the most pervasive. Interpreters and external commands can work together to create an injection risk. Select each item to learn more about them. Interpreters are programs that can make code platform independent. They read in the source program and its related data, and translate and execute the program, instruction by instruction, without requiring that the code be compiled into machine language. Although interpreters allow for dynamic typing, dynamic scoping, and reflection, they also make code susceptible to injections. Danger of an injection attack exists anytime a web application uses any type of an interpreter. Web applications commonly allow for the execution of external commands. These may include SQL requests, shell commands, and system calls. These external calls are a special weak point for applications. Based on how the call is made and what is being called, user-supplied data that is not sanitized, filtered, or validated, as well as hostile data, can be passed through an external interpreter to the attacker's intended target. SQL injection is the most common type of injection attack. Select each item to learn more. SQL injection is the most common type of injection attack. However, regardless of the language, any instance with poor separation between command data offers attackers the potential to inject text for your application to view as code. SQL injection has become a common issue with database-driven websites because attackers see the database as the ultimate prize. It holds most of the critical data for an application. SQL injection flaws are detected easily and exploited easily. Consequently, any site or software package with even a minimal user base is likely to be subject to an attempted attack of this kind. The vulnerability occurs when a SQL string is assembled by concatenating user input. Specifically, using string concatenation to assemble a SQL command is what leads to a SQL injection vulnerability. For example, this string item contains input from a user, but the database server can see it as SQL. The item variable is the dangerous one in this scenario. These commands can be used to alter query logic to bypass security checks, insert additional statements that modify the backend database, or even execute system commands. These attacks may also take the form of blind SQL injection. This form of attack is used when an application does not display data to a web page for consumption. Instead, an attacker asks the database a series of Boolean true or false questions in order to fingerprint the database and retrieve the data. Although a more time-intensive form of attack is more challenging to exploit, it can be done with automated tools. Do not think that SQL injections can only happen in Microsoft SQL databases, because all procedural languages allow for the execution of procedures inside the database. An attacker can inject an arbitrary SQL statement into any database structure that uses them. For example, Unix and Linux databases face the vulnerabilities as a Microsoft SQL database. Although SQL injections are the most widely known, there are a number of different injection types. Select the highlighted areas to learn about them. All SQL databases that were designed for big data do not use the SQL syntax. They can still be the target of injection attacks. Select each item to learn more. SQL databases that were designed for big data, such as MongoDB and CouchDB, do not use the SQL syntax, and therefore remove the threat of SQL injections. However, these databases can still be the target of injection attacks by attackers exploiting vulnerabilities in the client protocol wrapper of the associated API. The challenge with the various types of NoSQL databases is that there is no shared language between them. Thus, developers must be aware of the syntax, data model, and underlying programming language of the specific database in order to recognize the injection attack possibilities. Developers should focus on instances where an attack string can be parsed, evaluated, or concatenated into a NoSQL API call for execution by the database engine in order to determine risk areas for the NoSQL database with which they are working. Some common examples of injection attacks for NoSQL databases include array injection, schema injection, query injection, JavaScript injection, and piggyback queries. Take a minute to read about them here. Many architectures will use NoSQL databases for read-write activities, such as user profiles, authentication, transactions, and sensor data, and will push that data to Hadoop for more analytical type activities, such as recommendations, fraud detection and prevention, and predictive analytics. Be aware that injection flaws in your NoSQL dataset can infect your Hadoop activity. For example, If a hacker has injected malware for remote code execution into your NoSQL database, copying that data to Hadoop can spread the malware and increase your attack vector. The many types of injections bring many types of risks that be introduced by injection flaws. Exploitation of these flaws can lead to lack of accountability, data corruption and denial of access, hostile takeovers of entire environments, and a host of other issues that undermine the entire security triad. Select each item to learn more. Many injection types and many associated risks. There are quite a few prevention and mitigation strategies a developer can use to fight injection attacks. First, let's look at two that would have helped Cavalogys Corporation. According to the OWASP Top 10, the preferred method for separating data from commands and queries is to use a safe API that, if used properly, is secured for all input characters. This method bypasses the use of an interpreter entirely, or provides a parameterized interface. Remember Cavalogys Corp, where Hinata had discovered evidence of that SQL injection attack? Using a REST API for input validation would have prevented Simon from escalating his user privileges. Developers also can use ORMs or entity frameworks to mitigate injection risks. To negate a SQL injection is to use prepared statements when connecting to a database. This creates a separation between data and commands for the server. In our earlier scenario, Hinata had discovered evidence of an injection attack. A developer could have mitigated this attack by using a prepared statement to build a parameterized query like this. Note that prepared statements are only a mitigation strategy, not a preventive one. A parameterized stored procedure can introduce injection if the PL-SQL or T-SQL concatenates the queries and data, or executes hostile data with an execute immediately or exec command. Here are some more prevention and mitigation strategies to avoid SQL injection attacks. Select each item to learn more. Whitelisting input validation is also recommended for confirming user input. Well-structured data with a strong validation pattern, such as phone numbers, dates, postal codes, or email addresses, can be validated with regular expressions. Input from a fixed set of options, such as radio buttons or drop-down lists, can be matched to the exact acceptable values. Whitelisting is not a good option for input that requires special characters, such as text areas of mobile application APIs. Bind variables can be used instead of literals to improve security and performance. The variables are placeholders for the actual values in the SQL statement. A bind variable consists of a variable and a placeholder character that are replaced with the actual value at runtime. If your code requires dynamic queries, be sure to escape special characters using the interpreter's specific escape syntax and routine. The codes on this list are many that you can use. SQL structure, such as column names and table names, cannot be escaped. This makes user-supplied structure names highly risky. Limit their use. If a SQL injection attack does occur, using the limit clause may prevent the disclosure of all data. A limit clause limits the number of rows returned for a query. Row num in Oracle provides similar functionality. Do not give the web application full access to the web account used to access the database. Instead, write procedures to modify the data. Limit access to read-only whenever possible. Web application should only run the minimum privileges required to perform its functions in order to prevent against command injections. Do not run as root on the web server or use the DB admin role to access the database. In J2EE, use the Java sandbox. Select each item to review a few more prevention and mitigation strategies for injection. Recall that NoSQL databases do not use a SQL syntax, but they can still be the target of injection. Since they have no shared language, the prevention and mitigation strategies are a bit different. Review these strategies for NoSQL databases. Check your error codes, return codes, and all output to confirm that all processing has occurred correctly. This is a means of helping to determine if something has gone wrong and provides valuable input for assessing whether an attack may have occurred. Control or limit the use of third-party modules for form building and content management systems, such as WordPress, Drupal, or Joomla. These modules are known for having injection vulnerabilities. Just as an attacker can use fuzzers and scanners to discover injection flaws in your code, so can you. You can also review all calls to external resources, including where an HTTP request could be used in these calls. Be sure to stay up to date on the most recently identified vulnerabilities and exploitations. Although injections have been on the OWASP top 10 since its inception, they are still a type of flaw that plagues applications. Do not focus solely on SQL injections. As applications are built for new environments, such as cloud and distributed computing, new injection flaws are introduced. Developers must be aware that injection flaws can happen in a variety of places in an application, wherever inputs are allowed. Know your application framework, database, and platform, and the injection risks inherent in them. Now, take minutes to read this summary of what you learned.